the moderator, ASCE-Texas Section VP Educational, Brett Pope.
Thank you all for joining us today for Texas Section ASCE Webinar, 100-Year-Old Concrete Roadway in Texas. This webinar is the third in our series of monthly webinars for 2017. I'd like to thank the branches for hosting viewing sites all across Texas. As a state association for civil engineers, we're happy to provide this service to the engineering community. If you're not a member of ASCE or the Texas section, I invite you to become a member so that you can benefit from being a part of this professional association. Now I'm pleased to introduce our presenters for today's training. Bill Ciggalekis. Bill is the Chief Engineer for 100 Offices of Professional Services Industries, Inc., providing construction material engineering and testing services. Bill has 40 years of engineering experience providing materials engineering and testing services. Bill is a fellow of American Concrete Institute and has worked on many ACI personnel certification program committees and the Committee on Non-Destructive Testing. He previously provided plant certification as an auditing agent for the Post-Pensioning Institute plant certification for the international firms that manufacture ASTM A416 low relaxation 7-wire strands. Currently, Bill serves as Senior Auditor to the Pre-Stressed Concrete Institute Plant Certification Program and serves as a committee member on 4 of the PCI Quality Committees. Bill holds a BS in Civil Engineering from Rutgers University. Jan Prusinski. Jan is an Executive Director of Cement Council of Texas. He has over 30 years of engineering experience with emphasis in design, research, development, and utilization of cementitious materials in paving and construction. Previously, Jan has worked for the Slag Cement Association, the Portland Cement Association, Houston Lighting and Power, and Bechtel Power Company. Jan is LEED accredited professional and has served on numerous boards and committees with the American Concrete Institute, the National Concrete Pavement Technology Center, the American Concrete Pavement Association, and the Transportation Research Board. Jan holds a BS in Civil Engineering from the University of Michigan and an MBA from the Bauer School of Management at the University of Houston. He is a fellow of the American Concrete Institute. Take it away.
Thank you. I'm Bill Ciggalekis, and I'd like to start by acknowledging Don Talbert, Jan Prusinski, and the support of the Cement Council of Texas for their information and assistance in developing this presentation. The presentation today, not just a street, but a place in history, Belknap Place. This presentation addresses a pavement licensing process that was patented in 1907 and is gaining revitalized interest today. The presentation offers a historical perspective into the difficulty of construction that must have been encountered constructing this road in 1914 and the success of the 100-year use of this road. Last year, May, the homeowners of the historic Monte Vista district celebrated the dedication of Belknap Place as a Texas historic landmark. The place is from Dewey Place to Kings Highway in San Antonio, Texas. It's approximately 4,200 linear feet long, 40 feet wide, or approximately 18,700 square yards. The person, Augustus Belknap, was born in 1841, Newburgh, New York, served as a captain of the New York Volunteers during the Civil War, moved to San Antonio in 1877, and was instrumental in the founding of the city streetcars, president of the Opera House, director of the San Antonio Fair Association, Second Ward Alderman, councilman at large, and founder of a local militia, the Belknap Rifles. 25 years after his passing, the City of San Antonio, the State of Texas, County of Bexar, on July 1st, 1914, awarded to Texas Granitoid Company the city's share of $14,900 through the sale of bonds on September 1st, 1913, to finance the construction and the paving of Belknap Place. I mentioned that $14,900 was the city's share, and the local residents ponied up an equal amount, or for approximately $30,000, which today would have a net worth of about $75,372. In competitive quotes back in 2016, the amount of the construction in 1914 was about $1.60 a square yard. Competitive quotes last year would have been about $36 a square yard, or almost $900,000 to pave this road. It was clearly a bargain at its time, especially lasting 100 years. I'm going to talk a little bit about Road Construction 101. As civil engineers, I'm sure we're all aware of the basic process: laying out the road, shaping, grading the profile of the subgrade, moisture conditioning the subgrade, compacting the subgrade, laying out the forms, placing the concrete, and finishing the concrete surface. Back in 1914, surveying was performed with optical transits. Perhaps distances might have been measured by the chaining method. Today, lasers and computers make that much easier of an accomplishment. The state-of-art grading back in the 1914 era, this is a picture of a 1910 circa steam-powered grader that may have been used to shape and grade the road profile. The steam roller pulled a blade behind it. Today we have laser elevation controls, equipment with several hundred horsepower, and again, this task is so much easier. We have subgrade stabilization with lime cement, perhaps lime cement fly ash combinations, or other chemical admixtures to help in the stabilization of the subgrade. Back then, none of that was available. Today we have modern equipment for the pulverization, the moisture conditioning of the subgrade for improved longevity and durability. None of that was available in the 1914 era. Compaction in the 1914 era was probably a static roller pulled by a mule or horse. Today we have dynamic equipment with varying frequencies, amplitudes, or static for compaction and compaction control through quality measurements by independent testing laboratories. The quarrying of aggregate for the concrete for this particular road was identified as originating from Canipa, Texas, which is 110 miles west of San Antonio. The process called for a trap rock material in the top surface of the pavement, and this material was likely quarried with a steam-driven shovel and brought into San Antonio by rail. The delivery of concrete in the 1914s was either a crude dump truck, as we see in this picture. The first known delivery of ready-mix concrete to a job site was in 1913 in Baltimore, Maryland, and our street, Belknap Place, was placed in 1914. The estimate of 3,100 yards for our project was either delivered similarly to this dump truck, or might have been pulled to the job site by horse or mule cart, or it might have been mixed on site. Some of the mixing equipment of the era that was available, steam-driven equipment, the material had to have been manually loaded, shovel, and labor, and it had very limited capacity. We have a few pictures of some concrete mixing equipment of the era. Concrete placement might have been performed with a steam-powered counterbalance piece of equipment similar to the picture on the left, or again just with wheelbarrow and muscle. The finishing of Belknap Place, we have an actual picture of the road as it was being constructed. What was interesting, because the shaping of the subgrade was so difficult and the specifications required the crown of the road to be approximately 6.5 inches thick and the shoulders at the curb to come down to 4.5 inches, that the street pavement was actually shaped. The subgrade was held level and the concrete was placed with formwork to create this crown effect. And then the gentleman in this picture finished it, and I'll describe later the finishing process. Based upon the approximate number of joints that were counted on the road, this picture, the Belknap Place was placed in approximately 210 independent concrete placements. Concrete ready mix today can be computer batched. There's large silos for cementitious material. Back in the 1914s, cement was brought to the job site in canvas bags. Today we have chemical admixtures for retarding, long-term curing benefits. There are large aggregate storage and belt feed for automated loading of the batch plant. Today it's very easily to achieve concrete production in excess of 200 cubic yards per hour, while that would have been unheard of in a day at the time of 2014. Today, concrete can be delivered in 10 cubic yard ready-mix trucks. We have mechanical finishing process. The daily placement of concrete can very readily achieve anywhere from 300 to 1,000 cubic yards today. So the placement of Belknap Place today could be placed in as few as 3 days or perhaps 10 days on an average if we ignore intersections and other special considerations. This is the licensed process that we're talking about. It was patented in June 4th, 1907 by Blom-Sinek Company, Granitoid. The contract for Belknap Place was contracted to Granitoid of Texas. This patented process uses a two-course concrete placement, a large coarse aggregate in the lower lift and a denser graded concrete aggregate in the surface. It's a somewhat of a precursor to ACI 302, which offers the guidelines for a shake finish for slabs and floor construction that are for heavy industrial use. There were no laser screeds in the time. We were able to obtain a few cores from the road. The cores that we obtained were approximately 5 3/4 inches to 7 3/4 inches thick, so they apparently exceeded the 4.5 to 6.5 inch thick requirement. The road is constructed on a fat clay subgrade having a CBR of 2 to 4, and there was no chemical modification or improvement to that fat clay. The surface aggregate was a very hard, dense, black-colored stone, 3/8 inch to 1/2 inch, and it was visually identified as trap rock originating from Canepa, Texas, again, approximately 100 miles west of San Antonio. The fine aggregate in this material was the 1/4 inch trap rock screenings to dust, and there might have been some field sand that was used in that mix as well. The apparent estimated concrete mix had a composition of 3-3-2, or 3 parts trap rock, 3 parts sand, and 2 parts cementitious material. The cement was about 25%, and the trap rock and sand was about 75%. And visually, it's hard to separate the trap rock and the sand because we don't know whether that material was batched all together or whether the sand was added separately, and with the trap rock, how much of that fines were just part of the rock process. The bottom layer was a coarse-graded pit-run gravel local to the San Antonio area. The fine aggregate, a field sand, the apparent estimated concrete mix design of 3-2-1 is your basic concrete mix, 50% gravel, 35% sand, 15% cement. While joint spacing was not fully understood, we see some transverse cracks in this particular picture. There were many things that they were innovative and ahead of their time. Acute angles at joints were avoided. This process included a stamped concrete feature. This feature was not added for aesthetic purposes, but was thought to be a requirement for the sure footing of horses that pulled wagons up and down the streets at this time, as automobiles were just coming into their beginning. One of the interesting things is the first patent for stamped concrete was not granted till 1950 by Brad Bowman, and the Belknap Place preceded that by 35 years. Some of the achievements. There's what may have been, or what we would think today should have been, a cold joint. There were no curing compounds, no bonding agents, no set retarders, no water reducers, and this mix was placed in two separate horizontal lifts. We clearly see that these cores are upside down, but we clearly see that dense surface trap rock and the river gravel in the underlying portion. From published literature by the San Antonio, approximately 111 days per year, the average temperature in San Antonio is above 90 degrees, and there was no chilled water at the time of this concrete production, and yet they were able to place it, finish it, and get a good bonded two-course concrete surface that has lasted for 100 years. This is truly an amazing accomplishment. The performance of this road, today's city thoroughfare going to design to accommodate via metropolitan bus service would require 4,500,000 18-kip easels over a 30-year design period, with a minimum of 9 inches of Portland cement concrete. Belknap Place has been in service for 100 years. It's surpassed the current 30-year traffic design with varying pavement thicknesses, clearly less than the 9 inches and in the range of 5 3/4 to 7 3/4. This is the picture of Belknap Place back in 1914 as it looked in its pristine condition. This is a 1914 Model T car. So clearly the easel loadings early in the life of the Belknap Place did not have 18-kip wheels, as this vehicle was much lighter than the vehicles of today. In the 1950s, we see the same road. The cars of the 1950s were probably much heavier than the cars of today, so the road has seen substantial automobile traffic. 1980 and the 70s, the 60s, we saw the land barges of the era, and the street is starting to exhibit some of the crack control or missing joints that were not fully understood, as we see the longitudinal cracks starting to develop down the length of the street, but still the road was performing amazingly well. Today, 2016, the traffic on Belknap Place has school bus traffic, trash trucks, moving vans, commercial traffic, and residential traffic. While we did not conduct an average daily vehicle traffic count, I'm very confident that this street has exceeded the 30-year design life required of a street constructed today. History is man's story, We study, we learn from his story, his success, and his trials. In this picture, I was using an impact echo device to try and determine the thicknesses of the street, and I had a lot of confusing data because of the thickness of the pavement, the thickness of the overlying very dense concrete, but by using the relative thickness data and the relative maximum thickness data, we were able to select our core locations to verify what we assumed to be the good range of the thickness of this street. With some insight, while recognizing the durability and the success of Belknap Place, PSI advocates that current procedures, available technologies for the design of concrete mixtures, and the design and construction of new pavements should not be ignored. Moreover, the concept of this pavement and this process should be considered for incorporation into the available technologies for considered further enhancement of the durabilities of pavements that are constructed today. With special recognition, I'd like to thank Don Talbert, a friend, a mentor, a retired quality control director of Capital Cement. Don identified this place. He researched the original city ordinance. He obtained some of the funding and participated in the coring and the investigation, and he attended many of the meetings toward the presentation and the dedication of the historic landmark of Belknap Place. This is a picture of Don as he was received the ACPA, American Concrete Paving Association Lifetime Performance Achievement Award on behalf of Belknap Place. With that, I'd like to turn the presentation over to Jan Prusinski. Jan?
Yes, thank you very much, Bill, and I appreciate your involvement with this project, and definitely the leadership of Don Talbert, who even though he's been retired for several years, he was instrumental in helping us obtain the historical marker. My organization, the Cement Council of Texas, actually worked with the Monte Vista Historic District, and then we had to go through multiple layers of government, City of San Antonio, Bexar County, up through the Texas Historical Commission to get that historical marker. It's just not a given. It actually has to be very well documented, and we were able to do that. And truly, if you are in the city of San Antonio, either living there or you're bringing your family for a vacation, us being, most of us on the phone call are probably civil engineers, take them to a piece of 100-year-old infrastructure in San Antonio and show them how something that was really built at the dawn of the era of paved roads in general and the beginning of concrete technology. Really this predated even the establishment of the Texas Highway Department. It's truly an amazing it's truly amazing, and to find the marker, it's relatively simple. Bill told you that the approximate location of Belknap Place. It's just north of San Antonio College, but the marker itself, if you look for the United Methodist Church there, Laurel Heights United Methodist Church, is right on the northbound side of Belknap. It's right next to the church, and the church itself celebrated 100 years in 2016. So a lot of good history there, right there in Monte Vista. So what I'm going to do, and thank you very much, Bill, what I'm going to do is give you sort of a historical and maybe regional and Texas context for Belknap Place, and what was going on at the time within Texas, within San Antonio, and kind of a little bit like Bill, but in a sort of a broader sense of the industry, compared then and now. Let's see, just as sort of some introductory remarks, I also wanted to put it in today's context. Literally, things that we're seeing in the news over the last week, over the last couple of months. But when we look at infrastructure, I think we're all, especially being members of ASCE, we're all aware of the D+ grade that our national organization gave overall to America's infrastructure, which is extremely poor. I think we're all, being in this industry, we're all aware of this. And it's sad to think that 4 years ago, of course they do this every 4 years, sad to think that this grade has not improved in 4 years. Now, the hopeful item is that the other item in the news is that Donald Trump, love him or hate him, he's trying to map out a $1 trillion infrastructure plan that hopefully can address some of those items in the D+ and raise that grade. It's probably still insufficient. There still has to be sufficient local and state investment in these in infrastructure to bring our grade out of that D+. But this is certainly will be a jolt in the arm. And just a couple preliminary comments. As we as engineers design in the future, and with this context in mind, we of course want to make wise investments for the long term. And building things like roads that can last more than 20 years, building roads that are 50 or even ultimately 100 years is not a bad way to go. The actual incremental investment is surprisingly small to go from a road that lasts 20 years to a road that lasts 50 years. We of course, and Bill stressed this, we want to use the best modern technology that we have. So we want to incorporate everything that we've learned about construction and design and concrete and all these items over the last 100 years. But we also want to learn what worked in the past. And when you do have a piece of infrastructure like a 100-year-old road, that truly is something that you have to take pause and say, why did this last 100 years? And I will say this, that this is not an unusual road in that it lasted 100 years. You can, although they're not certainly common, you can go to many places throughout the United States and find 100-year-old concrete streets that have gone through similar celebrations, and actually, so surprisingly, several of them are the granitoid pavements that Bill was talking about, but a number of others have used other types of technology. I'd also like to refer you, if you really kind of enjoy this history, if you go to our website, which is www.cementx.org, we actually have an article posted. You can flip to it right after you get to the home page on Belknap Place that explains some of this in a little more detail, and actually has a slideshow there too. So if you're a pavement geek and really like this stuff, please go to our website and find out more about it. So let's just start with cement and talking a little bit about cement and concrete in general. And my organization is the Cement Council of Texas. We are the regional affiliate, the Texas affiliate of the Portland Cement Association. So, and actually, as I'm talking, I'm sitting in Chicago during a break in the Portland Cement Association meeting. So we're very aligned with the PCA and the national organizations like the American Concrete Pavement Association, National Ready Mix Association. And we are the trade association for the cement manufacturers in Texas, and what we strive to do is provide good information on design and construction to building professionals and constructors in the state of Texas. Now, cement and concrete, I'm not going to dwell on this. I think most of you know about this stuff, but Portland cement itself is, of course, made from limestone and other earthen materials. It's mined or quarried, and then it's heated to a very high temperature in a kiln. Comes out as kind of a rock-like material called clinker, and then it's pulverized into a fine material. It chemically reacts and hardens when it's mixed with water. That's why we call it hydraulic cement. And the word Portland actually comes about because the inventor or the original patent holder of Portland cement, Joseph Aspden, thought it looked like the limestone cliffs in Portland, England. So it has nothing to do with Portland, Maine or Portland, Oregon. It just was what it looked like to him. And again, another historical item that I don't have on the slide, but 2017 is actually the 200th year of the celebration of the patenting of Portland cement. It was patented in 1817. Now, concrete, of course, uses Portland cement, and it's a combination of Portland cement, coarse and fine aggregate, sand and water, and now, as Bill mentioned, other cementitious materials and different types of admixtures. The beauty about concrete is that it forms a fluid, moldable material, and then as it hydrates, it turns hard and gives you high amounts of durability if done right. And certainly Belknap Place is an example of concrete being done right. Now, early Portland cement development, I mentioned 1824, but the original patent was 1817. I believe that's maybe when he applied for it. In 1875, we had our very first cement plant in the United States, the Copley cement plant in the Lehigh Valley of Pennsylvania. And so as a country, we look to the Lehigh Valley as sort of the cradle of the cement industry, and there's a number of plants and companies that still reside there. But Texas was not far behind. In 1880, still one of the very first plants built in the United States, the Alamo, Portland, and Roman Cement Company was formed, and the kilns were built in San Antonio. Now let's talk specifically about San Antonio cement industry. And really, if you look back, the cement industry is large in San Antonio, and it's an essential part of the community fabric. And we'll bring that theme as we go on with this presentation. But San Antonio is essentially the cradle of the cement industry west of the Mississippi. So we're the first Western cement plant in the United States, and really still one of the very first cement plants built in the United States, the Alamo plant. Now, I mentioned the Alamo, Portland, and Roman Cement Company. It was incorporated in 1880, and it was a second U.S. cement plant after the one near Allentown. It was incorporated by a gentleman by the name of Lloyd and another one by the name of Coulter, and a few partners, but one of them was actually a drugstore chemist, and he helped formulate the original original formulations for the Portland cement in that was going to be developed at the Alamo plant. The other interesting thing is that for the first number of years of the existence of the Alamo, Portland, and Roman Cement Company, their office was above that particular drugstore, so that's where they resided. They used what was called a French burr mill. Of course, Portland cement was, the technology was more developed in Europe at the time, and at this plant it was a vertical mill, and it burned layers of limestone and coke. So it was kind of a long process. It wasn't as much of a continuous process back then. And the fineness, it was basically the QA/QC was that you wanted a 5% residue on a number 50 cloth, and that was before we had anything like an ASTM standard. And at the time, they could make 10 barrels per day, and it cost about $22.50 a ton, and for the Portland cement, and $18.50 a ton for the Roman cement. So there were two little bit different cements that they actually made at the plant. And then because nobody really knew that much about cement or concrete at the time, the company actually utilized a patented sidewalk construction method that they promoted to the city, and built a number of sidewalks themselves just to develop a market for their product and a demonstration of how good this product could be. So they actually had to get involved, sort of vertically integrate themselves just to get their cement product used itself. And eventually, this product from this specific Alamo plant was used in the Texas Capitol and the Driscoll Hotel, among other historic structures in Texas. Now, San Antonio's cement industry, one of the original presidents, he was originally the accountant for the, when in 1880 when they incorporated, he eventually became the president, Charles Baumberger. And you can see that he actually built a house in the Monte Vista district that still exists today, and it's a beautiful house. We actually, as part of that Belknap celebration that Bill talked about, the current owners of the house were gracious enough to allow us to have a cocktail party there the night before, and it's a wonderful place. It's in Monte Vista, and it's a concrete house, by the way. In 1908, that 1880 plant had outlived its sort of quarry lease from the city, and the quarry was pretty much mined out. Plus, the plant was quite inefficient for the demand that they now had. They had 1,500 barrels needed per day, and so they built a new plant in 1908. Now, this plant was built in an area of town that was actually just a little bit north of where the streets were and the streetcars went to, the horse-drawn streetcars, and it was called Cementville. It wasn't incorporated, it was just termed that because it was north of town, a little ways up. The workers, most of the workers actually lived on the site, so they had corporate housing, a corporate store, they built a swimming pool, they had a company band. It's interesting, if you go to Alamo's plant, which is now on 1604, the company still exists, they have a whole hallway filled with pictures of this and of the company band and the company facilities in Cementville. And that produced actually until about 1985. Now Charles Baumberger Jr., the son of the original Charles Baumberger, was the president until 1968. So it was a family affair, more or less. And then within San Antonio, the Capital Cement plant was built. Now, this is a different company, and most of you probably have heard, I'm sure, of H.B. Zachary. They built this, built Capital Cement because there's a great seam of limestone that runs through the area. And now it's termed Capital Aggregate, still owned by Zachary, ultimately. But that was the second cement plant or cement company that came to town. So now there were two cement plants. There was the Cementville plant and the Capital Cement plant, which is located near 410 now in San Antonio. And then eventually, in the early 80s, the Cementville plant ceased production, and then the Alamo plant, after the widow of Charles Baumberger Jr. died, they had no children, so the estate was sold to an Italian firm called Buzzi. It was their very first U.S. asset, but they understood the historical context of this plant, so they continued then and continue now to call it Alamo Cement, even though they have many plants in the United States now, all going under the Buzzi name, but this one in particular retains the name Alamo. And then, of course, nearby San Antonio, within 60 miles, you have New Braunfels. You have a Cemex plant just a little bit away from New Braunfels, Martin Marietta's plant. These are very large plants. And then Texas Lehigh, up just south of Austin, is a Buda plant. So if you look at a map, you're basically following the limestone seam across that kind of goes up I-35 there, and you can see you can see the various Alamo plants. The two lower ones are no longer functioning, of course. You have Capital Aggregates, you have the Cemex plant, Martin Marietta, further north, and then in that same time period within Texas, you still had cement in other places. You had the Texas Portland Cement Company that was formed in Dallas and then later Houston in 1900. Southwestern Portland Cement, very prominent company in El Paso, made cement. And then Trinity Portland cement into Eagle Ford. So Texas was a burgeoning place for the cement industry in the early 1900s. And currently today within Texas, you can see many of the plants along that I-35 corridor down around between Austin and San Antonio, and then up in the DFW area. It's actually all located, 3 big plants in Midlothian, and then a couple of plants in West Texas. This one Cemex, I have it labeled on the map, Cemex in Odessa. That actually just changed hands in December. Now it's GCC Rio Grande in Odessa, Texas. But we do have a lot of cement plants and capacity within Texas. So if you ask, well, how much do you have in Texas? If you look at these are very recent numbers. 2016 cement use within Texas, we had about 16.4 million tons of cement used in Texas, and if you compare it to California, which is the next highest state, they had about 10 million tons. We're more than 50% more cement use in Texas. And if you look on a national amount, we're about over 15% of the total national consumption of cement within Texas. And you can also look, we do track, say, state-led jobs. And Texas, by far, produces more concrete pavements. Now, these are state DOT pavements. They don't include local pavements. But about 20% of the paved concrete pavements let by DOTs are Texas pavements. Next state is Iowa. They're a very big, even though they're a smaller population state, they build a whole lot of concrete pavements. Most of their county roads are concrete pavements. And we have things that we can learn from, certainly from Iowa. So, you know, if you compare these numbers, the population of Texas, maybe about 27 million, is about 8.5% of the United States. So we're using well more than our share, our population share of cement and concrete. Now, back to the history. The automobiles were just getting underway during this whole historical context. I believe 1908 was when the Model T was introduced. And of course, dirt roads were a problem for automobiles. You know, horses could kind of track themselves somewhat out of the dirt, sometimes out of the mud, but cars got easily bogged down. And plus, in the urban areas, you had during dry periods, so for instance, in San Antonio, a lot of hot, dry weather, these cars would kick up dust, and you'd have urban dusting problems. Now, the oldest concrete street in the United States was in a place called Bell Fountain, Ohio. And a gentleman instrumental in this was named George Bartholomew. He was the founder of the Buckeye Portland Cement Company. This road still exists. This is a current picture of the 1891 street in Bell Fountain. But you know, I kind of feel like if you've ever seen the movie, the Greek wedding movie, I can't remember the exact title, but the father in there always said everything was, you know, everything was invented in Greece. Well, I feel like that with the cement industry, that George Bartholomew, everything is invented in Texas. He was in Ohio, but he learned about Portland cement production because he spent a lot of time at the Alamo Plant learning about it, and then he brought that technology up. So we have a small claim on that very first concrete road. We helped teach them about cement there. The road technology actually won first place in the 1893 Chicago International Exposition. So this was a burgeoning, innovative technology that was you know, precursor to a lot of good concrete roads and even our interstate system. And it recently celebrated its 125th anniversary. Now in Texas, here's a kind of a timeline of what's been happening here. 1898, you had your first paved road in Texas. That was Market Street at St. Mary's, and that was in San Antonio. Very first paved street, not concrete, of course. That was more of a bituminous type road. First automobiles, both in Texas and San Antonio, 1899. And then 1904, San Antonio began issuing its first road bonds, additional bonds in 07, 13, and 15. So very likely the public portion of this was probably funded with some of this road bond money. And then you have Belknap Place, constructed in 1914. And then 1917, again, a lot of 100-year anniversaries. TxDOT is celebrating its 100-year anniversary this year. So it's interesting. I was able to find a really interesting publication from the Agriculture and Mechanical College of Texas, and we all know about them now. But it was called Principles of Pavement Selection, and in this, they really went into a lot of great detail, and it's almost like this is Jan Prusinski. I'm hoping that you can hear me again now. I completely lost the signal for a second.
Yes,
so I'm going to. Okay.
Thank you.
I'm so sorry about that. It was I didn't push the wrong button. It just actually lost the signal. So I'm going to continue here. So with this table of contents, if you look closely at it, you can see that it talks about different types of Portland cement concrete pavement, and there were several patented methods. So this was a technology that was right on the, a lot of innovation happening. There was something called the vibrolithic method. There was granitoid, Hassam, and unpatented Portland cement concrete. He talked about the first cost, and then the cost of, and then they talked about durability of roads and the cost of maintenance. So they were already talking about life cycle cost of pavements. And then where you have a total annual cost of a pavement, kind of a life cycle thing. And then they actually document all paved roads in Texas in 1920. So this is a great historical document. And from this document, I was able to produce this this chart. And if you look, San Antonio is actually the largest city population-wise in Texas at the time. And it had fewer total paved streets than the city of Dallas. In thousands of square yards, about 1.5 million versus 2 million in Dallas. But look at the concrete pavement. They had about 25% of the roads were concrete by 1920 versus any other city had much lower percentages. So San Antonio was an innovator back then with concrete pavements, where a quarter of all their paved roads were, in fact, concrete. Another 100-year anniversary last year was the Portland Cement Association, and I'll just mention that they were instrumental, that association was instrumental in bringing things together like ASTM C1, the Cement Standards Committee. The American Concrete Institute was formed with a lot of PCA support, and they drove concrete technology through the century with things like water-cement ratio, a sand library, development of air entrainment, and now, for instance, MIT's Concrete Sustainability Hub. So Portland Cement Association has really driven a lot of concrete technology, and American Concrete Pavement Association helps drive some of the concrete pavement technology these days. Some other concrete milestones in Texas over the century, you had the Dallas Medical Arts Building built a little bit after Belknap Place, and at the time it was a 19-story reinforced concrete building, the tallest concrete building in the world at that time. You had a lot of state and local pavements being built like Belknap Place, but also in other areas. The first concrete road in Texas was actually not Belknap, but in Palestine, and it was itself a granitoid road. You have, many of you may be familiar with the Hilton Hotel on the river there, where they used precast elements to put the rooms in place during the hemisphere, the World's Fair in San Antonio. And roller compacted concrete pavement got its start in Texas at Fort Hood in the United States. That was the first RCC pavement. Even now, like at the Capital Cement Plant, they actually have something called Sky Mine, which is consuming some of the carbon dioxide that is produced, about 75,000 tons per year of CO2, and it's also avoiding another 225,000 tons by making industrial chemicals such as baking soda, hydrochloric acid, and chlorine. The cement industry in San Antonio and in Texas, but particularly San Antonio, has integrated itself so well that its old facilities have been essentially returned to the community as some of, as viable and really a lot of times very beautiful public spaces. We're talking about things like the Japanese Tea Garden, the Alamo Quarry Market, the Beckman Quarry and La Cantera Development, the Baumberger Endowment. Many of you have visited the Japanese tea gardens in Brackenridge Park. This is an early picture of those tea gardens, and you can see in the background the stack of that original Alamo kiln, 1880 kiln, that is still there. That is itself a historic site, and the quarry is now the garden part of the tea gardens. Here's another picture of the entrance to the tea gardens. You'll notice it actually says Chinese Tea Gardens. This entrance was erected during World War II, where unfortunately, for a lot of reasons, it was politically incorrect to call it the Japanese Tea Gardens, but they preserved that for historical context, I guess. And here's a picture of the kiln itself. It's really amazing to go visit this original 1880 kiln, and it itself has its own historic marker. And picture beautiful public space within San Antonio, and there's a nice little restaurant up top that you can grab sandwiches and enjoy the history and the beauty of the Japanese tea garden. And of course, we've got the Alamo Quarry Market. If you go up Highway 281 through the middle of San Antonio, a few miles north of downtown, you'll see these stacks. These were the original stacks of Alamo Cementville plant, and now you have a very successful high-end mixed-use development there that incorporates these same stacks. So again, amazing redevelopment of these industrial sites. Now the Beckman Quarry is not associated with cement in particular, but a lot of the aggregates were used for concrete, certainly some for buildings, some for asphalt. But the Beckman Quarry, owned by Martin Marietta, guess what's there now? ASCE-Texas and the La Cantera Development. So that's been developed and turned into very valuable public spaces. One of the things that's probably not well known about the whole Alamo story is something called the Baumberger Endowment. I mentioned to you that the Baumbergers, Charles Jr. and his wife, had no children, but they really loved the community and they loved children, and as what they did was all their millions of dollars that went from the sale of the cement plants to Bootsy and whatever their accounts were at the time were given to something called the Baumberger Endowment, given by Charles Baumberger Jr. And all this money is used for scholarships, college scholarships for students that reside in Bexar County, Texas, which of course is the San Antonio area. And they place particular attention on students who otherwise would have difficulty affording college. It's not merit-based per se. It's, students that have A, B, or sometimes even C averages can apply and very well may be funded by this Baumberger Endowment. And you get $5,000 annually for 4 years, which can be a significant help to your tuition and living and board expenses. And amazingly, since 1979, $45 million has been given to 3,200 students in the area. That's to me a huge legacy, and it's there because of ultimately the beginning cement industry in Texas. I mentioned the Belknap Place celebration. This is a map of exactly where that place was, and this is if you go to that Methodist church, it's on the corner of Belknap and Woodlawn. You'll find a historical marker right there. This is the concrete house, the Baumberger house. This is a picture inside the house, so we're inside the concrete house. This is one of the owners, the lady in the center is one of the owners, and one of the VPs from Alamo Cement on the left there. And then here we had, during the celebration, we had San Antonio's police chief being entertained by a barbershop quartet, and Speaker of the House, Strauss, and a Texas state senator attended the event. This is the president of the Portland Cement Association, looking at some of the vintage cars that showed up and standing on Belknap Place. And you can see those cracks, even though they formed, they're more like joints. Most of them have not vaulted. They're not a performance issue. And this is Bill giving his talk at the place. We had a couple hundred people show up there, and then we unveiled the Don Taubert on the left helped me unveil the plaque for Belknap Place. Here's a couple of pictures. Bill showed you this one. This is Belknap Place then, and I was able to find the same view today. You can see this fence on kind of the fence on the right. That's the same fence that you're seeing there, that sort of cobbled fence. And so this is the same view. And if you look at the electrical, at the wooden electricals, it looks like they're the same ones that were there 100 years ago. Another picture, you saw the construction photo we showed you. Behind it is the Kohler House, the owner of the Pearl Brewery, and that you can see that fence there. Well, that's the same view today. So you're looking at what they constructed there, and there's the fence, and there's the road. So amazing that you can kind of go and compare. That's the end of my presentation. I certainly invite you to view the historic marker. Also, please visit our website, cementx.org, cementx.org, or contact me, and I would be more than happy to tell you more about Belknap Place or anything cement or concrete related. Thank you very much.
Thanks, Jan. Thanks, Bill. We do have a few questions from the audience. First few are for Bill. The first one is, what was the design compressive strength of each layer and current core strength, if tested?
The strength was not specified. There was the specified surface mixture of the concrete to include the 3-part trap rock, 2-part cement, and in the lower one it had the approximate 3-2-1 mix that was specified, but there was no specified strength per se. And we had very limited cores. The cores were not tested for compressive strength based upon the impact echo and what I would use the empirical relationship to strength. I can only guess or estimate that strength is about 4,000 to 4,500 psi.
Okay. Are there records of the subgrade soil and how the subgrade soil was prepared? And if so, what are the properties and methods?
Again, the specifications required that the subgrade be shaped and compacted to a firm foundation. Density testing was not performed at the time, and our sampling in the core locations through Atterberg limits indicated that it was a fat clay, and that's all we can say at this time, is that they must have done a pretty good job in compacting and preparing, but there were no density tests or moisture density control.
Okay. And then what was the slump of each of the two layers, and was it changed due to weather or experience?
The slump of the concrete was essentially no slump concrete. In the specifications, they reference tamping and compacting the concrete into place. So looking at the concrete and based upon the durability of the concrete, it was not placed as conventional concrete would be placed today. It was a very low slump or no slump concrete.
Okay. This one's for Jan. What distinguishes Roman from Portland cement?
The Roman cement is a lot slower to set up, and I believe, and I'm not an expert on Roman cement at all, but I believe it was also used in masonry mortars, so it was more conducive to that type of construction.
Okay. And got one more. Not sure who it's directed to, but feel free, one of y'all take it. Is there a consideration of imposing a load limit on the road to reduce potential for unacceptable cracking?
I'm not aware of anything, Bill. I know that I'll tell you this much, that the Monte Vista Historical District is very proactive in keeping their history alive. And this road, neither of us said this, but this road, portions of it were actually overlaid with asphalt many years ago, maybe because they felt it was kind of bumpy for cars or something with the brick-like stamping. And that you can go and you can see vestiges of the asphalt overlay, but that's weathered and worn off almost completely. And at this point, the Monte Vista District wouldn't stand for the city to come in with another asphalt overlay. They understand the historic nature of the road, and so they want to preserve it. I don't believe that there's been any engineering done to say we really need to, keep buses off or, 18-wheelers off. It supports those loads now, and I think they're content to having it continue in that capacity. But I have talked to both the city and Monte Vista about what can we do, what kind of studies can we do to make sure that the road gets preserved beyond, that those cracks don't, like water doesn't go into those cracks. Maybe we need to have some type of sealing program or something like that. I'm not sure what, but there may be some minor maintenance that ought to be looked at for the road.
As I've walked up and down that street, I have never seen any signs that limit or prohibit types of traffic on the road.
Okay. Well, thank you both very much. Thank you again for participating in today's ASCE-Texas Section Webinar. As mentioned before, individual registrants should receive an attendance acknowledgement without further action. For those attending with the group, the site coordinator will receive the PDH certificate for distribution. Tomorrow's webinar is from our T&DI chapter, Mitigating Risk While Playing Hurricane Russian Roulette with the Houston-Galveston area, from Colonel Len Waterworth, Texas A&M Galveston. Our April webinar will be a geomorphology topic entitled When Rivers and Infrastructure Collide, from Stephanie Kaufman with Fries and Nichols. I invite you to visit the Texas Section website, texasasce.org, to register for the webinars, to learn more about the association, and to take advantage of the benefits of your membership. You can also watch 2016's recorded webinars on demand and earn PDHs. I'm always available for your questions and hope to hear from you soon. Thank you for your attendance. Have a great day.
This concludes today's webinar. Thank you for joining us. The session will now close.